Hi, welcome back to another brief video clip that we're gonna have that I'm recording right now for this class. Uh, Today we're gonna talk a little bit about energy, and obviously energy is the subject that you're reading for this week, and in particular the reading assignment outside of the regular textbook, the reading out of the Road to Rio. Now, it will be very difficult to go ahead and deal with such a contentious issue as that of energy within only a couple of minutes, but I want to take this opportunity to highlight at least one thing. I want you to pay very special attention to the term peak oil, and that is used in that particular reading. I want to stress that for our purposes, peak oil does not refer to oil in general or obviously to energy. It refers only to conventional oil, the oil that is lifted out of the ground without really having to go through extra steps for processing it. That is to say, one of the major suppliers of oils to the United States is the oil that comes from Canada out of the tar sands. That is not considered to be part of conventional oil, and so is not included in the calculations about what people mean when they speak about peak oil. Neither is the oil that we're going to be getting out of shale, nor the oil that comes out, the heavy oil that comes out of Venezuela. So the concept peak oil refers only to the fact that according to most geologists, we are at the point whereby we have already lifted 50% of the oil reserves that we know about. And so every single barrel of oil that we're going to lift from here on is going to be leaving us with less oil and less oil. And as you can imagine, the greater is going to be the use of oil. If it is going to become scarcer and scarcer, then obviously its price is going to increase. And so eventually the question becomes, are we in a situation whereby we'll be able to provide enough alternatives for the energy that we are dependent upon from oil right now without having to pay an extraordinarily high price? Because as we probably all will know, or we should know, that this civilization of ours, this modernity, is really built on the concept of having relatively inexpensive oil. So there comes a point whereby we will not run out of energy, but we will never be able to really lift that particular last drop because it would be so expensive for us to go ahead and do so. So the other concept that is very crucial when you speak about energy is what is known as net energy. That's to say, you don't want to go ahead and spend, say, for example, 10,000 BTUs in order to discover or to lift only 9,000 BTUs. In that case, it wouldn't do you any good. And so, quite a lot of the oil that is still available is really hidden. We've got to drill down deeper. It is much more difficult to get at, i.e. we've got to use more energy in order to lift that oil, so the net energy that we get out of it definitely is much smaller than the net energy that we used to get out of oil that was easy to get to. For example, the first oil well in the world was the one that was discovered in Pennsylvania. It was discovered at a depth of only 69 feet, while right now in certain cases we're drilling as deep as probably 2 or 3 or maybe even 4 miles. So definitely the energy and the technology that is embedded in that particular process is much more difficult than what we used to have to use around 150 years ago. The other small things that I think I should mention that could help you understand the overall image about energy supply and consumption in the world is to keep in mind that normally when you speak about energy, we speak about it in terms of what is known as quads. Quads are really nothing else but 10 to the 15 BTUs. They're known as quadrillions. So it's quadrillions of BTUs. The United States consumes every year a little bit over 100 quads. The whole world consumes only just about 500 quads. So as you can see, the US consumes around 20% of the overall energy in the world. Now that is important. By the way, so what is quad? A quad is a BTU, and the BTU is the energy that is needed in order to raise the temperature of a pound of water by 1 degree Fahrenheit. So it's an awful lot of energy. Now, why are we concerned about that? Well, the issue is that you've got to make sure that there's enough energy. You don't care what is the fuel that is available to you. What is much more important is to have the energy. However, when you look at the portfolio of sources that we have, we find out that we are very much dependent on oil. There are actually many things in the world that we cannot do except with oil. Let's say, how would you be able to run the airplanes or the cars or some of the ships in the world? All of them are really dependent on oil. So it's very important, therefore, is that as the oil decreases, we've got to find another alternative to replace it. Now, what is absolutely of the interest is that studies have shown, beyond the shadow of the doubt, that our overall quantity of energy by 2030 is expected to increase. So we will be producing more energy in the world as a whole. Actually, if you want the exact figures, I think we will go up from around 63 to 73 billion barrel equivalents of oil every single year. So that looks to be quite good on the surface. However, what is very unfortunate about it is that you'll find out that conventional oil is going to drop, and is going to drop substantially. However, the production of non-renewables is going to increase in order to compensate for the drop of oil. So we do wind up with a greater amount of energy as such. But the bad side of this particular equation is that also these same projections, these are very sophisticated projections by some of the best labs that we have in the United States, are suggesting that there will be a tremendous demand gap. That's to say, our demand will increase much greater than our supply. And so we will wind up with a tremendous gap that needs to be plugged somewhere, somehow. So how are we going to plug this particular gap? We don't have the conventional oil, therefore we are really going to be limited only to the non-conventional. But even the non-conventional, such as tar sands and shale, are also a little bit limited. They will increase, but they cannot increase that much. So the unfortunate part of this story is that neither with renewables, by the way, renewables have very, very, very many great limits, because actually even up until now, most of the non-renewables are not economically feasible. They exist only as a result of the subsidies. So that leaves only one way to plug in that particular gap, and believe it or not, that is only really coal. So many people right now think that we will eventually be forced to go back to coal if we are to plug that gap without cutting down on demand. So as you can see, there is another side to it that very many of the environmentalists would like to push, and that's to say this gap we shouldn't think of plugging it only by increasing supply. Why don't we think in terms of also increasing demand substantially? But the question becomes, as you can see right now, we're going to go full circles. Would you be able to decrease demand substantially if we're going to have 9 billion people, and if you really believe that each of these 9 billion people is deserving of an adequate standard of living? So it really becomes very problematic. Eventually, unfortunately, it looks that we're going to go back to non-conventionals and to coal and obviously to the nuclear option. So the simple assignment on the blog is for you to go ahead and write something about whether you would be willing to accept an increase, or whether you'd favor an increase in the use of nuclear energy. Okay, bye-bye.